The examples in this video go with section 6.2, the law of sines. This is part 2. Example 1, solve triangle ABC with angle A equal to 49 degrees, side A equal to 32, and side B equal to 28. All right, let's see what our picture is going to look like. We will draw our triangle. And we'll put angle A right here, which they told us is 49. And then side A will be right here, which is 32. And then we'll put angle B up here. And side B down here will be 28. And that will make this angle right here angle C. And you can see we have an angle side-side situation. So we can have either 0 triangles, 1 triangle, or 2 triangles. Okay? All right, so let's start with the first triangle. We are going to use the law of sines. We need to find angle B first. So the sine of 49 is to 32 as the sine of angle B is to 28. We can solve this by cross multiplying. We'll have 32 times the sine of B equal to 28 times the sine of 49. Let's divide both sides by this 32. That gives us the sine of B is equal to 28 sine 49 divided by 32. And since we're solving for B, we would say that angle B is equal to the inverse sine of 28 times the sine of 49 divided by 32. And when we put that in the calculator, it will give us our value for angle B. Make sure you're in degrees. And rounding to 1 decimal place, that gives me 41.3 degrees. All right, so this triangle, this angle is going to be 43.1 degrees. Now, if there is a second triangle, okay, then that means we're going to have a triangle that looks more like this. A is still going to be 49, B is still going to be 28, and side A is still going to be 32, but this angle B up here, if there is a second triangle, will be 180 minus 43.1. And that gives me 138.7. Now, since 138.7 and 49 add together to give me 187.7, which is greater than 180 degrees, because triangles can only have 180 degrees in them, that means there is no second triangle. Or you can run the test, one of these, and since we already know there's one triangle, it says that side A needs to be greater than side B, and if we go back here, side A, 32, is in fact greater than side B. So either way, you can go ahead and solve for your first angle and then see if a second triangle is possible, or you can go back here and run the test to see how many triangles you're going to be looking for. Okay, now that we know there's only one triangle, let's finish this up. We now have side B. We need angle C and side C. Well, angle C is just going to be 180 minus angle A minus the angle B we just found. And that gives me 87.9. All right, all that's left to get here is side C. And I'm going to use angle A with side A because that was our given information. The sine of 49 is to the side 32, just as the sine of 87.9 is to side C. Let's cross multiply. We'll have C times the sine of 49 over here on the left, 32 times the sine of 87.9 on the right, and we're solving for C, so let's divide that sine of 49 to the other side. That means that side C is equal to 32 times the sine of 87.9 divided by the sine of 49. All right, and let's put this in our calculator and see what we get. And this is going to give me 42.4 when we round off to 1 decimal place. And now our triangle has been solved. Example 2, solve triangle DEF with angle E equal to 31, side E equal to 3, and side D equal to 6.2. Round the measures of unknown angles and sides to 1 decimal place. Again, let's draw our picture and see what our triangle looks like. Here's D and E and F. Angle E is 31, side E is 3, and side D 6.2. So we have our angle side-side situation. I'm going to have to figure out what angle D is first, and then we'll have to find out the two parts of F. We'll start off with the law of sines. So the sine of 31 divided by 3 is the same as the sine of angle D over 6.2. Let's cross multiply. We'll have 3 times the sine of angle D equal to 6.2 times the sine of 31. And let's divide that 3 away. The sine of D is equal to 6.2 times the sine of 31 divided by 3. That means angle D is equal to the inverse sine of 6.2 times the sine of 31 over 3. Now, let's put that in our calculator and see what we get. And my calculator is giving me an error. It says domain error. And so what that means is no triangle exists here. Now, if we wanted to go back and run the test instead of trying to solve this triangle, okay, that is going to be this one right here. Now, H, it turns out, is actually equal to B times the sine of A. So we want to know if side A is less than B times the sine of A. We can go back here, and we want to know if 3 is less than 6.2 times the sine of 31. And 6.2 times the sine of 31 is 3.2 when we round it to 1 decimal place. And it is less than. So because it's less than B sine A, we could have said that no triangle exists. So you can do either way. You can go ahead and try and solve a triangle like you normally would, assuming that there is one. But if you get an error, no triangle exists. Or you can go back and you can run the test, and you could determine without trying to solve the triangle that no triangle exists. Example 3, solve triangle GHI with angle G equal to 40 degrees, side G equal to 22, and side H equal to 25. Round the measures of the unknown angles and the third side to 1 decimal place. Let's start with triangle 1, and let's look at a picture of our triangle. Here's angle G, which we know is 40. Here's angle H. We know nothing about that, but we do know side H is 25. And then here is angle I, which we know nothing about, but we do know that side G over here is 22, and you can see we have our angle side-side situation. We'll have to find angle H first. That means we're going to use the sine of 40 is to 22, just as the sine of angle H is to 25. Let's cross multiply. 22 times the sine of angle H is equal to 25 times the sine of 40. We'll need to divide that 22 away on both sides. The sine of H is equal to 25 times the sine of 40 divided by 22. That means H is going to be equal to the inverse sine of 25 times the sine of 40 divided by 22. All right, let's put that in the calculator and see what we get for angle H. This gives me 46.9 degrees. If there is a second triangle, then we know that angle H up here is going to be obtuse rather than acute. Angle G is going to stay 40 degrees. Side G will stay 22, and side H will stay 25. But angle H up here, and I'm going to call these primes so we can differentiate them between triangle 1 and triangle 2. This angle H up here is going to be 180 minus 46.9. And that gives me 133.1. And when I add 133.1 to 40, that gives me 173.1, which is less than 180 because a triangle can have 180 degrees in there. So that means there is a second triangle. And so we'll work on that in just a minute. Let's finish triangle number 1. All right, we should find angle I next. Angle I is going to be 180 minus 40 minus 46.9. That gives me 93.1. This angle right here. And now we need side I right up here. And again, I'm going to use G and side G. The sine of 40 degrees is to 22, just like the sine of 93.1 is to side I. Let's cross multiply. We'll have I times the sine of 40 degrees is equal to 22 times the sine of 93.1. Let's divide away that sine of 40. Side I will be equal to 22 times the sine of 93.1 over the sine of 40. All right, let's put that in the calculator and see what side I is. And if I round this, this is going to give me 34.2. Okay, so here are my solutions for triangle 1, angle H, side I, and angle I. Okay, now let's go work on triangle number 2. All right, so here is our obtuse triangle with our given information marked. We still have G being 40, side G being 22, and side H being 25. And now we are going to, let's see, we found H prime. We said this was going to be 133.1. H prime is 180 minus 46.9. which is 133.1. And now we need to find angle I and side I. It'll probably be easier to find I first, the angle I first. Actually, we have to, because we can't get over to the side I without it. Okay, so there's 180 degrees in a triangle. We're going to subtract off angle G. We're going to subtract off angle H prime. And this is going to give me 6.9. So this angle right here, 6.9. Very, very small angle there. All right, now we can find side I. And again, I'm going to use my data from angle G and side G here. The sine of 40 degrees is to 22, just as the sine of 6.9 is to side I. We'll cross multiply. I times the sine of 40 is going to be equal to 22 times the sine of 6.9. Let's divide away the sine of 40 on both sides. I, side I, is equal to 22 times the sine of 6.9 divided by the sine of 40. That means side I, let's throw this in the calculator, is going to be equal to 4.1. All right, so for triangle number 2, here's our angle H. Here's our angle I. And I should probably put the degree signs on here. And here is side I. So when you have to solve for 2 triangles, you're going to need to show the solutions for both triangles, triangle 1 and triangle 2. And it's best if you label which one's triangle 1 and which one's triangle 2. So here's my triangle 1 and my solutions for triangle 1. And then we drew a new triangle, triangle 2. And here are my solutions for triangle 2. And that's all there is.